Today we're going to jump into section 2.2, which is simplifying variable expressions. And previously what we were doing was in section 2.1 evaluating variable expressions. Simplifying is a little bit different. What we're going to be doing is combining a lot of the variable terms together, the constant terms together, and we'll be discussing what that looks like here today. So let's go ahead and jump into the notes. There's a lot here. My suggestion would be to go onto Canvas. At the bottom of the home page, there's a link to every single one of these notes, and so I really suggest going in and maybe just having a copy of this downloaded or printed off, just that so you can refer to it. There's a number of different properties here that we're going to look at. These are all just properties of real numbers that we deal with on a daily basis. A lot of times you might not even think of many of these properties at work, but in reality they're all over the place in the real world. They help us out in a lot of different places. So I'm just going to briefly talk through these. I'm not going to go through detailed examples of every single one of these. I really want to get into the meat of this lesson, which is a little bit further down. So the properties of real numbers, there's the commutative property. And the commutative property basically means that you can swap the position when you add, and it's the same thing. Same thing when you multiply. So a times b is equal to b times a. That's what commutative means. You're moving it or flipping the order in which you multiply or add. The associative property is exactly the same idea. So when you add, say for example, a third term, a plus b plus c, you can actually just swap out where the parentheses are, because the order of operations when you're adding doesn't really make a difference. So that is the associative property for addition. For multiplication, again, same kind of idea. For multiplication, when you use the order of operations, you can just multiply everything here and then multiply that, or you can multiply everything here times your a. It's really not going to matter. You're going to get the same solution no matter what. Down here are some of the important properties that I do want to touch on. 5, 6, 7, 8, and 9. Okay. First is the addition property. And you've known this probably since a young age, but if you take 0 and add it to anything, it equals whatever you started with or whatever you added it to. So if you take a and you add 0, that equals a. If I take 10 and I add 0 to it, you're still going to get 10 in the end. It's not going to make any difference. So that's the additive 0. Okay? Multiplicative 0 is a little different. When you multiply 0 times anything, what do you get? You get 0. A little side note for you. The whole concept of 0 is actually something that's really, in historical terms, something that has only been really understood in the last probably 500 years, which you're probably thinking, so what? A majority, you have to understand, there was most of the math that was done up until about 500 years ago was a lot of geometry, and it was related to things in the physical world. And so the idea of 0 was very misunderstood, because how could you quantify anything that had 0, whatever length or distance or quantity, like the amount of how do you have 0 apples? How do you physically represent that? It was very confusing for a lot of people because everything was tied to the physical world. And so what's interesting is even the full concept of 0 didn't really work itself out mathematically until just in the last few hundred years. The whole idea of infinity actually was more understood by the early mathematician than 0. That's kind of crazy when you think about that, but that's actually true. So anything times 0 is 0. Multiplication, when you multiply 1 times anything, you get whatever you started with. So 1 times a is equal to a times 1 is equal to a. The inverse property, okay, the inverse property. What this is saying is that if I take any number and then I add its negative, so let's say, for example, I have the number 12. If I take 12 and I add it to negative 12, I'm going to get 0 every single time. Okay, and that works in reverse as well. For multiplication, so bear in mind, the inverse of addition is subtraction. The inverse of multiplication is division. So if I take a times 1 over a, I'm going to get 1. The same thing applies for the opposite. If I have 1 over a times a, that equals 1. Okay, so if you multiply a number by its reciprocal, a reciprocal is when you take whatever your number is and you flip it over itself. You multiply those two numbers together, you're always going to get 1. Okay, and then the distributive property is a rule that says if I have a times b plus c, then that's the same. What you do is you multiply the a times each term inside of the parentheses. So a times b plus a times c. So we'll go through some examples of this. Here's an example of simplifying using the property of addition. Same thing with the property of multiplication and the distributive property. These are just more for your use if you want to kind of see a few different examples just written out. I'm actually going to work through quite a few here. So let's go ahead and switch over to my whiteboard. I wonder how long I'll have this whiteboard available to me until it shuts off, which is a common trend, it seems like. All right, so use the given property to complete the statement. So question 14, this is asking us to use the commutative property. Commutative. I always spell this wrong. Commutative property of addition. Okay. And what is the question? So 9 plus 17 is equal to question mark plus 9. So the commutative property, remember, is the order. So 9 plus 17 is equal to question mark is going to equal 17. Right? If I put 17 in here, it's going to be exactly the same thing. Just the order is reversed. Okay, that's 14. Let's look at number 20. The inverse property of multiplication So this question is asking us to do 1 over minus 5 times, and they actually put it in brackets here. Okay. So remember, if I go back to the notes, let me pull it up here. If I go back to the notes, remember that the inverse property of multiplication, which is right here, says that if I have a number times a, that's going to equal what? This reciprocal times itself is going to equal 1. Okay? So there it is. So that right there is our solution. I want to show you another way to write this. When you have multiplication, you can, well, actually no, I'm going to leave that there. That's fine. We're just going to stop at that. Okay? I don't want to confuse people. It's part of the trick of teaching is not to teach too much, just enough to be dangerous. All right, question 40. This is saying to simplify. When you see this word, what you're doing is you're combining your like terms. So when I say like terms, I mean the variable terms that are alike and the constant terms that are alike. So all constant terms are alike with one another. Variable terms, it depends on what the variable is. So in this case, question 40 is saying 12x plus 13x. Okay? So when I go ahead and add this together, notice how there's an x common between each of these terms. One term is 12x, the other term is 13x. So because these have the same variable, I can actually add them together. What you do is you add the coefficients. So 12 plus 13 is going to be 25, and I'm going to bring along my variable for the ride. Okay, so that's question 40. Question 48. Minus 3a plus 12a is equal to 9a. Okay? So, well, actually, I just wrote this out. This is actually the solution. So here's the question. See, now you have the heads up as to what it is. The a is common, right? That's the same variable. So now I'm going to add the coefficients. Minus 3 plus 12 is going to be a positive 9. And then I bring the a along for the ride. Okay, so that's question 48. 52. Minus 15 xy plus 3xy. What is this? Now notice this actually has multiple variables in each of the terms. So this first term has minus 15 as the coefficient, a variable x, and a variable y. This is still the same term. This guy right here, this variable term, also has an xy. Now because these are the same, xy here, I can combine them. Okay, so this means that I add the coefficients, minus 15 plus 3 is equal to a minus 12, and the x and the y come along for the ride. Okay. I do want to point something out real quick. So you may see something like this. If in case you see this, this right here is an equivalent expression to what's above. Notice how the y and the x, I changed the order. But remember, if you go back to the properties that we dealt with, this is the commutative property of multiplication. They are exactly the same thing. A times b is the same thing as b times a. X times y is the same thing as y times x. So in this case, you still can combine these terms. This would still be a minus 12xy. You can put it in any order you want. It doesn't really make a difference. If you do x times y or y times x, normally what we do is we put them in order alphabetically. So x comes before y, which is why we usually write it like this. All right, let's go ahead and take a look at question 54. And again, this is asking us to simplify. We have minus 7ab plus 7ab, and that is equal to what? So I have the same variables in each term, so I can combine the coefficients. Minus 7 plus 7 is 0, and I have ab. But remember, 0 times anything is equal to 0. So because of that, this again goes back to the multiplication property of 0. Anything times 0 is equal to 0. So that is going to be our solution right here, is going to be 0. So that makes sure that there's a distinguishment between 1ab and 0ab. If there's nothing written in front, it's a 1. If there's a 0, then the whole thing is 0. Okay, let's do another one, 64. Minus y squared minus 8y squared plus 7y squared equals. Now here's the thing. The y squared, this again is kind of its own variable. You can think of y squared as y times y. So these all have the same variable associated with them, which means that we can combine the coefficients. So we have a minus 1. Remember, there's a minus y is just a minus 1 in front of here as a coefficient. So minus 1, minus 8, plus 7. This is the same thing as a minus 9 plus 7. And that is going to be what? A minus 2. So here our solution is minus 2. And notice how I did the coefficients separately here. 9 plus 7 here is going to be a minus 2. You can do that, that's fine, as long as you're combining like terms. So like terms are the ones with the same variables in them. So this is going to be y squared. Minus 2y squared. That is our final answer. Okay? All right. Let's take a look at question 70. We're going to mix it up a little bit. I think there's going to be a couple of different variables here, and so we'll have to make sure that we combine the right ones. 7a minus 7b plus 12a. Okay? So notice there's a b here and there's an a here. I can't combine the b's and the a's unless I'm multiplying, but I'm not doing that. I'm adding, right? There's the thing that's separating these two is an addition sign, so I can't combine them. So what I can do though is I can combine the minus 5b to the minus 7b and the 7a to the 12a. So the things that are circled I can combine, the things that are underlined I can combine those separately. So my solution, let's just do the a's first because we normally go in alphabetical order. 7 plus 12 is going to be 19, and I have an a. And then a minus 5 minus 7 is going to be what? Minus 7, minus 8, minus 9, minus 10, minus 11, minus 12. Minus 12. And then the variable connected to those is b. So this right here is actually our fully simplified final answer. 19a minus 12b. All right. And remember, the order, again, doesn't matter. You can write minus 12b plus 19a. Again, remember the commutative property of addition. It doesn't matter which order you put them in. It's exactly the same equivalent answer. Okay? All right. I'm going to go through a bunch of these examples here, and hopefully we can, this will be a really good help to you. 3x squared plus 5x minus 10x squared minus 10x. Okay? So again, I like circling things that look the same and then underlining things that are a little different. So I notice that the x squareds here are the same. The x's separately are the same. So this is going to be 3 minus 10 is going to be a minus 7. 5 minus 10 is a minus 5. And the terms that are connected are the x squared for the 7. And for the x, we're going to do just the x. So this right here is our final answer. Question 82. It's the same idea. We're going to be simplifying. This is minus 2 times 5a This is the same thing, so we need to distribute this. This minus 2 is going to multiply inside the brackets. The minus 2 times the 5 is a minus 10, and then the a comes along for the ride. Okay? So that's question number 82. Question 86. 6x times 12. Okay. When you have coefficients times numbers, you're actually taking the number here, so this is just a constant, and it's multiplying by that coefficient. So 6 times 12. Can I do this in my head? I know that 6 times 5 is 60, so then I add 12 to 60, and that's going to be 72. 72x. Okay. So that's number 86. Number 90. Minus 12b minus 9. So if you don't have these memorized, there are different kind of tactics to just doing the multiplication or the arithmetic quickly. A lot of it is just mental kind of math. So for example, if I see like a 12 and a 9, I'll think, okay, like what's 12 times 10? 12 times 10 is 120, and then I would subtract 12 from 120 to get 12 times 9. So that would be, what, 108? I think that's pretty much, yeah, that's going to be 108. So minus a minus is going to be a plus, so 108, and the b is going to come along for the ride. 94, 1/5 times 5a. Whoops, there we go, 5a. Remember how when we go back to the notes, I want to switch back here. When I have the inverse property of multiplication, if I have a times 1 over a, or 1 over a times a, that equals 1. Well, really, that's kind of what we have here in this instance. So you have 1/5 times 5. Because of the 1/5 times the 5, that's going to equal 1. And again, the a comes along for the ride. So your variables are kind of just following what's happening with the multiplication between the numbers. So 1a is just equal to a. We don't need the 1 in front to demonstrate that it actually is just 1a. 98. All right, we're going to introduce some fractions in here so you can see how this works. 4/3 times 3x over 4. Okay. Now what I like doing in these instances is I like just multiplying across and then making its own new fraction. So in this case I have 4 times 3 times x, and then, so that's, again, I'm just multiplying 4 times 3 times x in the numerator, and then in the denominator I have 3 times 4. Okay. So multiplication, remember, is you can go right across. If it was addition, it would be different. You would have to find common denominators, and we'll get into that in a little bit. But for now, let's just focus on the multiplication because it's a lot easier, actually. All right, so take a look. When I'm dividing, if in the numerator and denominator I have the same thing, I can actually cross them out. So that goes away, the 3's go away, they cancel with one another. And what I'm left with is just x over 1. So x divided by 1 is just itself, which is x. So that is our solution right there. All right, 110. Here I have 16y times 1/4. Now you can think of this when you combine them as this whole thing right up here is like in the numerator by itself. It's like 16y divided by 1, right? Kind of like what we had here, x over 1 is equal to x. Well, 16y is just kind of starting here and going backwards. So you can rewrite it if you want as 16y over 1 times 1 over 4. And then just rewrite it kind of like we did here. So 16 times y times 1 all over 1 times 4. The 1's cancel. How many times does 4? So we're left with a y, and we're left with a 16 here, as well as a 4. The question is, how many times does 4 go into 16? So I'm going to use my handy-dandy fingers. 4, 8, 12, 16. How many fingers? 4 fingers. So that means that I am left with a 4y. Okay? There it is. It's 110. Let's keep going. Making some good progress here. Again, I just want to go through a lot of these examples. I just think that it's going to be really helpful for us. So 120 minus 5 times a plus 16. Okay, this is where we start to get into the distributive property. So remember, just as a reminder, let's go back to the notes. The distributive property says that I have a times b plus c. I'm taking my a, whatever's sitting in front, and I'm multiplying it by each of the pieces inside of the parentheses. So that's what we'll do here. This minus 5 times a plus a minus 5 times 16. So this is equal to, so you can see I took the minus 5, and I multiplied it by each individual piece. Okay, you can draw the little arrows right there if it helps you. That's perfectly fine, but my suggestion would be to make sure that you write the whole thing out. So minus 5a, I don't think we can do anything with that, but minus 5 times 16 we can. All right, what's minus 5 times 16? Trying to think about this one. There's really no quick mental math way of doing it except just do it. 6 times 5 is 30, and then I'm going to be adding that to 10 times 5, which is 50, so that would be 80. This would be a minus, so you know there's a minus sign in front. Minus 80. Okay. So there is our solution. 122 minus 5 times 3y plus 7. Again, I'd really encourage you to get comfortable with this. We do a lot of using the distributive property throughout this course as well as future courses. So this early stuff is really crucial. Okay. So notice we're doing the minus 5 times 3y, and then we're also doing it times the 7. So this is going to be a minus 5 times 7. And then when we multiply this out, we get minus 15y. And we get a minus 5 times 7 is a minus 35. So that is the solution. All right, let's do 128, and then after this one we have a couple more, and then we'll call it quits. I'm ramping up the level of difficulty here. Man, why does all these problems I picked have a minus 5 as the thing sitting out in front? So I'm not sure why that is. And of course my camera just shut off. I knew it was coming. I think there's like a 30-minute timer on it, so this is the halfway point. I'm just kidding. All right, here we go. Minus 5 times 7. So this is the same as a minus 5 times 7 minus 5 times a minus 10x. Okay? So again, you can see how I'm doing the multiplication by each piece. Okay? There's a minus 5 right there, and then the minus 10x is going to be multiplying right there. So now we have minus 5 times 7 is a minus 35. Minus 5 times a minus 10 is a minus 50. Oh, positive, sorry. Minus times a minus is a positive. So minus 35 plus 50x is our solution. All right. Let's do 136. 5. Hey, it's positive. Yay. Not a negative 5. Okay, so again, distributive property. The 5 goes multiplying to each piece individually. So 5 times a minus 6x squared. So the whole thing gets multiplied by that value. Okay. Plus 5 times a minus 3. Okay, the minus 3 is right there. So let's go ahead and multiply this out. Now the 5 is going to multiply by the coefficient here, which is minus. So 5 times a minus 6 is a minus 30. The x squared comes along for the ride, and now I do 5 times a minus 3, and that's equal to a minus 15. All right, just a few more. These questions go pretty deep on this page in this section. Minus 6b. Oh boy, now we got something with 3 terms. How are we going to do this? All right, so notice I've got a minus sign out in front. So what that means is you can assume that there's a minus 1 right there. Okay? And now, because we have 3 terms, take a look. This distributive property applies to every single one of those terms, just like we did above. The only difference is we just added something at the very end. So this is going to be a minus 1 times 8b squared minus 1 times minus 6b minus 1 times positive 9. Okay. So the minus 1 sitting out in front is just going to negate the terms or the signs that are connected to each of these pieces inside. So minus 1 times 8b is going to be a minus 8b squared. Minus a minus is a plus 6b. Minus a 9 is going to be a minus 9. And that is our solution. I don't know if you can see it right there. I have this light in my office that sits right smack dab in the middle of my whiteboard, and sometimes it is very annoying. All right, now we're going to combine all of the stuff that we've done up to this point together into some more difficult problems. Joy. 156. 10 minus 2 times 11x minus 3. Okay. So we have a constant term sitting right there. And then we have the distributive property that's needed right here. So when you handle or when you have these kinds of problems, ignore the constant and just do the distribution first. Okay? So bring the 10 with you and then do the distribution. So minus 2 times 11, just like you did before, 11x, minus 2 times a minus 3, okay? And now, again, 10 comes along for the ride. 2 times an 11 is going to be a minus 22x. A minus 2 times a minus 3 is going to be a plus 6. Okay? But we're not done yet. We still have a little bit to go. Okay? So notice how this guy right here and this guy right here, they're both constants. We can actually go ahead and combine them. So 10 plus 6 is going to be 16 minus 22x. That guy is fully simplified. Okay, so that is our final answer. All right. $164. Oh boy, we've got a few different distributive properties here working. So how do we do one of these? These ones are always out to get you, but we just have to outsmart it. So when you have multiple distributive properties that need to be done, you start from the inside and you work your way to the outside. So I'm going to ignore everything except for just distributing this part right here, okay, the small part. So let's go ahead and rewrite this all out, x plus, and now we do the distribution here. So 2x, 2 times 7, so this will be 2x plus 2 times 7. There's our big bracket at the end. And now we can go ahead and combine our like terms and multiply. So we've got 2 times, notice, x here and 2x here. So I've got 1x and 2x. I can combine them into a 3x. And then 2 times 7 is going to be 14. Now we do the distributive property again. So the 2 goes to the 3x and also to the 14. So this is going to be 6x, 2 times 3. Oh, sorry. Got to write it out. I don't want to simplify it yet. 2 times 3x. I'm used to jumping the gun on these quite a bit, so I just have to tone it down. All right. 2 times 3 is equal to 6 times x. 2 times 14 is equal to 28. And that is going to be our final answer. Okay, so this again is kind of an example where you have the distributive property a couple of times. Okay. All right, let's do one last one, 170. 5y minus 2 times y minus 3x plus 2 times 7x minus y. Wow. Okay. So what we're going to do again is distribute these numbers to each of these pieces, and then we'll just work it out. So the places where we don't have to distribute, they're just going to come along for the ride. Minus 2 times a y and a minus 2 times a minus 3x, 2 times a 7x, 2 times a minus y. So minus 2y minus 2 times a minus 3x plus 2 times 7x plus 2 times minus y. Okay? All right, so let's multiply all these pieces out, and then we'll combine our like terms when we're finished. Okay, minus 2y. Minus 2 times a minus 3 is going to be a positive 6. Don't say that's a minus 5. I know a lot of people are probably going to add. That happens. 2 times 7 is 14, and the x comes along. And then I've got a plus 2 and a minus y, which is a minus 2y. Okay? So now let's look at all the terms. I've got a y, I've got a y, I've got an x, I've got an x, and I've got a y. So the y's, I'll underline the y's, and I'll circle the x's, okay? Just to distinguish. So 5 minus 2 minus 2. So 5 minus 2 is 3. 3 minus 2 is going to be 1, so I'm left with 1y. And then let's combine the x's. 6 plus 14 is going to be plus 20x. Okay, so if I wanted to write this in fully simplified form, 20x plus y. Remember, I do it in alphabetical order. Okay. The 1 is assumed. I don't need to write it. That's just what it works out to being. That is basically it. This is section 2.2. So again, if anyone has any questions, don't hesitate to email me and let me know, and I'll certainly work with you. In any case, I hope you have a great one.